Here's a quick summary of the different types of spanning tree and the advantages and disadvantages of each. So the original version of spanning tree is the IEEE 802.1d spanning tree. This is the legacy standard of spanning tree that was used when bridges were around, so it's very old, but it's the basis of other versions of spanning tree. You'll also see the term CST, or common spanning tree. This assumes that there is one spanning tree instance for the entire bridged network, regardless of the number of VLANs. We don't use that today in Cisco environments. We use a version of per VLAN spanning tree, or PVST. Originally, PVST only supported ISL. PVST Plus supports ISL and 802.1q, but today we often refer to PVST Plus as PVST. So this is a Cisco enhancement of spanning tree that provides a separate 802.1d spanning tree instance for every VLAN. If you had 100 VLANs, you would end up having 100 instances of spanning tree. Each spanning tree would have its own root and would do its own calculations. In Cisco environments, each spanning tree would send its own BPDUs, or bridge protocol data units. So if you had 100 VLANs, every 2 seconds, 100 BPDUs are sent. Multiple spanning tree tries to optimize PVST by mapping multiple VLANs to the same spanning tree instance. So 802.1s, or multiple spanning tree, allows you, for example, to have 2 spanning tree instances and then split your VLANs between those instances. VLANs 1 to 100 could be associated with instance 1. VLANs 101 to 200 could be associated with instance 2. That provides a lot of advantages in that you have 2 instances of spanning tree rather than 200, which you would have if you used PVST. Multiple spanning tree also has rapid spanning tree built into it, so it converges very quickly. Rapid spanning tree, or 802.1w, improves convergence over the 1998 version of spanning tree by adding roles to ports and enhancing BPDU exchanges. It provides for much quicker convergence when compared to traditional spanning tree. Rapid spanning tree, however, only supports a single instance of spanning tree. So all VLANs are mapped to that single instance, and this is why we have a rapid PVST Plus on Cisco switches. That allows us to have one spanning tree instance per VLAN, but have rapid convergence. Now, multiple spanning tree has the advantage that you can map multiple VLANs to a single instance of spanning tree. That, however, only becomes important when you have many VLANs. If, for example, you only have 10 VLANs in your enterprise, Rapid PVST Plus works really well, and hence it's the default spanning tree on Cisco switches. You would only necessarily need to use multiple spanning tree if you had hundreds or thousands of VLANs. So the default today on most Cisco switches is Rapid PVST Plus, provides rapid convergence, and allows you to configure one spanning tree instance per VLAN to optimize performance. In the videos in this course, I'll show you a campus network where we optimize spanning tree by splitting the load between different switches. In other words, one switch will be the spanning tree route for some VLANs, and another switch will be the spanning tree route for other VLANs.